These are going to be a continuation of the notes that we took yesterday together in class. We didn't get a chance to go over any examples. So you should have finished page 189, the real world link. Today you're going to look at some more examples and take some notes on some of those examples, and then go ahead and finish up some homework on page 194, numbers 1 through 5. I am not in my classroom, and so the writing and the paper that I have is a little bit smaller. So if you're having a hard time seeing it, then I am using examples straight out of the book, so you can also follow along with the book. So there's no excuses to why you can't copy these notes down. You can listen to what I'm saying and also follow along in your book if you need to. The first example that we're going to take a look at is example number 1 on page 190. And I've already got it written there. I have a graph drawn that shows amount earned in the y-axis and time in hours on the x-axis. I don't have grid paper, so if my line looks like that it's not perfectly straight, it probably isn't. But the one in the book is, and it is gridded, so you could count out or do whatever you needed to do with that graph. The problem says the amount of money Robin earns while babysitting varies directly, which is what we talked about yesterday, with the time as shown in the graph. Determine the amount that Robin earns per hour. So we're trying to figure out how much she makes every hour while she babysits. The time, the amount of money that Robin earns directly varies with the hours worked, okay? So we put amount earned, which is our y, over x, that's our time. And then we start to pick out points on the line. For example, if we picked out 2, 5, so at 2 hours, how much does she earn? Roughly about $15. So the points would be 2, 15. Okay, y, 15 to x. What does that point represent on this line? That point represents that in 2 hours she makes $15. So this line represents her amount of earnings. Okay. How would you find the constant of variation? We would put the amount earned over time, which is what we've got. And then we would go ahead and try and figure this out. So 15 over 2 is going to give us 7.5 over 1. So that's our unit rate. So if we pick another point on the line, say for 3 hours, it's roughly 22.50. So if we divide 22.50 by 3, we also get 7.5 over 1. Let's pick another one just to double check. At 4 hours, it's about $30, or 7.5 over 1. So Robin earns $7.50 per hour. Okay? Again, that's example 1 on page 90. Here's another example. 2 minutes after a skydiver opens his parachute, he has descended 1,900 feet. After 5 minutes, he descended 4,750 feet. If the distance varies directly with the time, at what rate is the skydiver moving? Again, this has to be the distance varying directly with the time. Okay, so our distance is our y, our time is our x. So if we put 1,900 over 2, we get 950. If it's varying directly, this will tell us that it is, because we should get the same. 4,750 feet in 5 seconds, we get also 950. Now, the only part we needed to add to this, which is why I waited to do it until I was doing the video, is that the problem says, and it's talking about a skydiver, so a skydiver is falling and descending. So that means we need to do what to this? If you said negative, that's right. These are going to be negative 950 because it is descending. okay? So that line is going to be going down if we were to graph it, okay? Okay, the last example we're going to go over is on page 191. It's example number 2. And angle here may be a little bit weird, so actually let me try something here. I'm going to move this. There we go. That's a little bit better. Okay, so I'm looking at this table in red. Right here is where we are. So the problem reads, and again I'm looking at example number 2 on page 191. A cyclist can ride 3 miles in 0.25 hours. Assume that the distance biked in miles y varies directly with time in hours x. This situation can be represented by y equals 12x. That's what we talked about yesterday. Graph the equation. How far can the cyclist ride per hour? So it says make a table of values, then graph the equation y equals 12x in a direct variation equation. M represents the slope. We already knew that. So the slope of the line is going to be 12 over 1. Okay, so let's make a table. This is called a function table, and we're going to start with hours 0, 1, and 2. So I've already got that filled out. How far did the cyclist ride in 0 hours? So in this y, so I have 3 columns. I have hours, that's my x. I have y equals 12x, that's my function. And then I have miles, which is y. Okay? So I'm going to take my hours and I'm going to plug them into this y equals 12x equation. Okay, for example, in 0 hours, I'm going to put 0 in here. How far does the cyclist ride? 0, because 12 times 0 is 0. Okay, that's going to be my y. That's my y. So this y is corresponding with this. We're trying to figure this out. In 1 hour, how many miles does the cyclist ride? 12 times 1 is 12. Okay. In 2 hours, the cyclist can ride 24 miles. Okay. And so on. I could go as many hours as I wanted. This is my y equals mx, and our slope is 12. We just found that out. Slope is 12 over 1. Okay. Problem told us that, and we're trying to figure out miles. So, what does the slope mean in this problem? It means that the cyclist can ride 12 miles in 1 hour. What are some other words that we could use for slope here? Constant rate of change, hopefully you're thinking of. The unit rate, okay, this is the unit rate. How do we know that this relationship is proportional linear relationship? It's a straight line. If we graph it, you're going to graph it here in just a second, you'll find that it's a straight line. And it is going up every single time by this slope. Okay? So what I'd like you to do is go ahead and fill out 2 or 3 more of these hours. Find out what their miles is by completing y equals 12x. Whatever your hours are goes in the x spot. And then go ahead and graph. Again, I've already got your x-axis and your y-axis labeled, so then you just have to fill in those points. This point would be 0, 0. This one would be 1, 12, 2, 24, and so on. Okay? Okay. There are a few more examples before you get to page 194, but your job now is page 194, 1 through 4. If you get confused, please go back to your notes. Please take a look at the examples that they have there and work to try and figure the problem out. Don't say, I don't understand, and then just give up. Please keep working. Whatever questions you have, we can talk about on Thursday. We are also going to have a quick quiz on Thursday as well, so don't forget about that also. Please be respectful and good for the sub, and use your notes to work on your problems. If you finish early, then you can go back and do whatever homework problems you have not completed for this week. Thank you. Have a good rest of your day.